So yesterday you took a test on slope-intercept form and graphing lines. Today you're going to start to look at something called a linear system of equations. And a system of equations just means we're going to take and look at what happens when I take two linear equations and I graph them together. Can I find a solution or solutions that satisfy both equations? So we're going to do this by graphing them. We're going to graph each equation separately. So I'm going to rewrite the two equations. This is just a notation out here. You don't need to worry about that. First equation is this one, and I rewrote it over here. I'm going to do the same thing that we did last week. I'm going to put this into slope-intercept form. So I'm going to subtract x from both sides. I'm going to put negative x plus 12, so it's in slope-intercept form. Divide by 2 on both sides, remembering that I'm going to divide 2 this way, which gives me negative 1/2 x, and also this way, which gives me plus 6. From that, I can pull out my slope and my y-intercept now. My slope is my coefficient to my x. It's negative 1/2. My y-intercept is 6. Now, I'm going to graph that. I'm going to go over here. I'm going to go to 6. And I'm going to use my slope of negative 1/2. So I'm going to go down 1, right 2, down 1, right 2. Do that several times. When you're graphing a system, it's best to use your slope as many times as you can so that you can be really accurate with your line. You need your line to be as accurate as you can get it. Connect them. Don't forget to put arrows. Now, because we're going to be graphing more than one line on the same coordinate grid, we need to label that line. So we're going to label the line with the equation. And I'm going to do it by writing it right out here.
Excuse the interruption. Students should be heading out to late buses in the next 5 minutes or so. Thank you.
All right. I'm going to take the next equation. It's this one here. I'm going to rewrite that. That one happens to be already in slope-intercept form, so I don't need to do all the algebra. But I'm going to pull out the slope and the y-intercept. Slope is 5/6. The y-intercept is negative 2. Start at negative 2. I'm going to graph the slope of 5/6. So up 5 and then right 6. Up 5. Doesn't fit. You can only fit those two, but that's okay because you'll notice something interesting there. Again, I'm going to label that line. Good. So we've graphed the linear system on the same coordinate plane. So we have two lines we graphed on the same coordinate plane. Let's look at the questions down below. Name the ordered pair where the graphs of the two linear equations intersect. So where do they intersect? They intersect right here. That point is point 6, 3. I'm going to label it on here. That ordered pair is the ordered pair 6, 3. That point is the only point that both satisfies or works in both equations. So if I plug it into this equation, it should work, and if I plug it into this equation, it should work. They want us to test that out. So to verify that the ordered pair we named here works in this equation, we're going to substitute it in. So where I have a y, I'm going to put my 3, and where I have an x, I'm going to put the 6. So 2 times 3 plus 6 equals 12. Is that true? Well, if you pick up your calculator and you go 2 times 3 plus 6, you get 12. So yes, it verifies or it checks. So that solution works in this equation here. Now let's check to see if it works in this equation. I'm going to do the same thing. 3 is my y, equals 5/6 times 6 minus 2. Well, if you put this into your calculator, 5 over 6 times 6 minus 2, you get 3. So it checks. The last question, could the point 4, 4 be a solution to the system of linear equations? That is, would 4, 4 make both equations true? What do you think, yes or no? Well, if you said it does not, it could not, you are correct. These are two straight lines. They can only intersect in one place. It can't curve back over and intersect in another place. So if this is my point of intersection, 4, 4 can't be another point of intersection. So no, because they can only intersect once. Pause the video here if you need to, and make sure you have all that written down. At this point, you can turn the page and try number 2. Once you have number 2 completed, turn the video back on and check your work. Once you've checked number 2, pause the video again, try number 3. And then when you're ready, turn the video back on and check your 3. When you're done checking number 3, raise your hand and ask a teacher for your homework, which is note page number 127. Good thing I didn't end it. Sorry. That's note page 125, not 127.